Monday. We're doing it again, and I just changed the numbers, all right? So, here's what I'm gonna do. I'm gonna erase all this. We're gonna rock and roll. I think I got this, right? I think I did. Okay. Okay. So we're gonna have 4 problems. There's a lot of parts to it. Richard, you gotta turn that on. I'm looking at what you're doing. Either you're gonna do your work or I'm gonna take that laptop from you. Okay, all right, Rich, I'm gonna come check with you in a moment, man. Can't do that in class. All right, so look, we do. We're gonna go ahead and do that. Is this recorded? Yeah. All right, so let's jump down to the we do questions. Let's start with number 1. Is this what I need? Thank you, Rich. All right, so looking at the first problem, I'm going to do it quick because it's Wednesday. First thing you do, who can tell me what you do when you're trying to convert the number? Who remembers? What's the first thing you do? You put it over 1, all right? So this is your we do questions. And all we do, number 1, we want to convert this from meters to kilometers. So the number they gave us was for the E. coli bacteria, which is what you get when you eat raw meat, like Burger King or something like that, it's undercooked, which is why you don't do that, is 6.8. All right, you put it over. I get some water now. Times 10. And that's raised to, in this case, -6 meters. You're gonna put that over 1, right? Next, you want to convert it. So it's multiplied by another fraction. Remember, and I'm working quickly, to get to kilometers, you gotta know how many meters are in a kilometer, right? And that's, if you know what kilo means, that's 10 to the 3rd power, or 1,000. So we say, hey, 10 to the 3rd, or 1,000 meters is equivalent to 1 kilometer. Okay. We can cross out something here. For the sake of time, it's going to tell you. It's meters. Thank you. No, it's cool. I appreciate that. When you focus, you can own it. You just got to keep you focused. All right? And that's 5, by the way, if you had your document open, okay? Rewrite without the crossouts. He said it right out of nowhere. Meters. 6.8. Absolutely correct. 10 to the -6. Meters is gone. So we just write what's in the bottom. 10 to the 3rd. And I can't keep stressing this. Please write down all your notes. Who is he? Okay, thank you. All right, we still got to calculate this. Remember, you're supposed to have this step, and that step. Some people are just putting all of it together and it looks like garbage. Type your notes right, because that's how some people lost points. Stop being sloppy. All right, so come down 1, we calculate. And if you know your math, this is going to raise it to -3, negative and negative make -9. Or you calculate it. So it'd be 6.8 times 10 now, raised to the -9. And it's a kilometer. That's the answer to that one. Number 2. Number 2, you're going to need probably page 18 of the book. So let's go ahead and knock this out. So that'll be, remember how many dollars they gave us here? Let's see. They gave us $32,000. We got to convert this into two ways. So part A. So part A, the problem is you need to first write the number, put it over 1. $32,000 over 1, and then we got to convert it. This is also something you got to do in your UDO problems. Some of y'all are using Google to give you a final answer. You got F's on that. You can go back and get the full credit, but you can't just say, well, it's this. You got to show them how you got it. Okay, you got to prove your work. Because the Google answer is wrong. All right, now, what are we doing this time around? Well, in part A, they ask us for millidollars. Now, if you don't know, milli is times 10 to what power? Use page 18 of your book. You can tell me. Anybody know? You got it. 5 points, sir. Thank you. So we have 10 to the negative 3, right? And this is meters. You want to make sure this is equivalent to 1 milli dollar. Okay? We can cross out, oh, that's wrong, dollars. I put dollars down there. It's the end of the day. I'm tired. We can cross out dollars here and then calculate. So that would look like this. All right, dollars divided by dollars is 1. And now we're effectively in millidollars. We got to rewrite to calculate. So we got 32,000 now.
Did you put a cost for that dollar?
Huh?
Did you put the cost for the dollars?
The dollars here?
Yeah.
Yeah, it struck out. And it struck out here because they cross each other out, right?
I can't see the line.
Oh, okay. Yeah, it's a purple line here, bro. So dollars is gone, but millidollars is remains. So leave that last. And then remember, a milli is just 10 to the negative third. So this is going to be equivalent to a millidollars once we calculate it. Okay? So like last time, we're going to just, like I said, calculate it. And by the calculator, do I have one? You put in a fractional form. And what you want to say is, top part is 32,000. Then you press down. 10x is how you raise something to 10 to some power. It's a negative 3. I get 3.2 E7. So that means it's going to be a power of 10 to the 7th, right? So 3.2 times 10 to the negative 7, and this is $1 million. Box that off. That's part A.
You wrong.
This continues. This is still part 2. Part B of the problem is a different conversion. So to do that, you can take the same number and put it over 1, right? Dollars. What in the world? Oh, okay, yeah. We're gonna cancel it out, and this time around, we need to figure out what does part B asks. $cent-dollars. Again, on your quiz Friday, you need to use table 1.4 on page 18 to figure that out if you don't remember. So, what is a centa? Okay, you can come on up, have a seat over here. Come on. Centa is 10 to the negative what? 2. Thank you over there. That's Nelson. 5 more points. So we know 10 to the negative 2 dollars is equivalent to 1 centa dollar. Okay? We can cross out dollars yet again. So this crosses out and this crosses out. Okay? Rewrite and calculate. So 32,000, right? All divided by 10 raised to the negative 2. This is going to be equivalent to 1 centa, or just centa dollar. Calculate. Well, yeah, y'all ask. Yes, you got to put all that because y'all be like, I got it right. Yeah, you want the full credit, you got to put it all down. So, looking at this as -2, this is going to give us 2 more zeros. So you can do it in a calculator or you can do it mentally. If I come here and I just take this same equation, right, the same formula, I can literally go in, put it in the bottom, and just raise this instead of to the -3rd power -2, and I get just 1 down, 3.2 times 10 to the 6th power. And this will be a form of centi dollars, okay? That is the end of problem 2, parts A and B. Make sure they go together one by one. Now for 3. I always do. Yep. Okay. So we'll box this off. So now, hey, bring it back, We're doing too much. Come on. Number 3. And number 3, this is a volume issue, right? So we need to set up our equation and our known unknowns. V is equal to. Yep. Okay. So now what do? No, you gotta write that equation. You need that, right? And all these can be only measured in meters only. All right. So let's go ahead and do that. Known and unknowns. What do we know about this problem? Well, first we got to set up our ingredients, but then we'll do that, right? Because we got to convert this to just meters, and all we got is centimeters. Some people are multiplying the numbers together, but don't know centi is not what you just leave by itself. You got to convert that. So what's the first value? Think about it. It says it's 2,023 centimeters. McCord, after that student comes out of there, you got to lock that up because we're going to have that problem again. So this says Y, right? So it's W is equal to 2,023 cm, but you can't change that. And we remember what centi was, so we did it here. So instead of that, it'll be 2,023 times 10, and that's to the -2 meters. We're gonna do the same thing for each of our variables. A lot of students mess this up, so please get all the steps. All right. Next is, in the problem, they give us Y, which is, not Y. Slow down, Mike. Long length. We just did Y. That's 1,187 cm. Again, cannot use that. We still put it in here because we have to show all our steps. So the length actually will be 1,187, but it's times 10, and you're going to raise that to the -2 meters. Once we get all our meter values, then we can calculate. All right, one last variable, and then I'm going to jump down to 4, which a lot of people didn't finish, right? I'm going to be real with you, some people left the 43 or whatever the age was in. You're supposed to put your age in there, not mine. I'm just using my example, and use your own number of age. All right, height. How high is it? Look at our page. It says that is exactly 749 cm. We're going to convert that value, right? We have to, because we can't use centimeters in here. We got to use meters only. So 749 times 10 raised to -2 meters. All right? We got all our values converted correctly and listed. Last but not least, what are we being asked? We asking for our volume. Question mark is going to be in meters cubed. You got to raise that to exponent. Some people just put meters 3. You got -5 if you did that. So fix your documents. All right? Stop being lazy. You got to raise that with superscript instead of subscript. That's taken to an exponent because meters times meters times meters is meters cubed. That's why it's meters to the 3rd power. All right, next. This is like part 1 of your notes, but you're going to continue on, right? So volume. This is where you put your numbers in. Let's go ahead and knock this out. Volume is equal to, use parentheses for each of these. Use your metered values. 2,023 times 10. You're going to raise that to -2 meters. Times, keep it going. That's 1,187 times 10. And that's raised to -2 meters. Times You got one last value in this sequence, 749 times 10 raised to -2 meters. Okay? All that goes in there. Now to calculate it. It's best if you use your calculator. If you're using Google, just make sure you use parentheses and treat it like a computer science program. So if I look at this, the actual answer, because we did this before, is going to be 1,798. I know I'm gonna be out your way, man. I know I'm not made of glass, but I got to get all the problems. And I'll take a picture too, so don't panic. And this is meters cubed. That's fine. I still got to finish it. All right, that's the end of problem 3. Problem 4. Let's finish out strong. So what do we got? Number 4. All right, now, to do number 4, you got to remember we did the age calculation, but they're additions. So you got to slow down with it because each addition is included with a dimension. All right? Yellow? So that becomes this, right? I'm going to start off with this. Maybe I give somebody 5 points, see who remembers. How old is Mr. Tyler? Y'all said it all together. Okay. How many people said it? 1, 2, 3. Y'all got to act. I saw you, man. All right. So 10, 10, 10. That's making sure you paid attention. They all said it. I was like, last time y'all said 4 to 650. I was like, that's messed up. I'm not that old. Huh? Yeah, 10 points because y'all remembered from Monday. I told you, we talked about this. I'm not done with the recording, man. Can I finish? I'm still recording. You might get close to 50. Let me see, all right? So let me finish this off. The last part of it all, because I'm looking at this time, is real quick. Again, do not put 43 for your age in this calculation. You put in your age. Whatever age you are should be there, and that's the number you calculating with, not Mr. Tyler's age. So 43 years old, that's how old I am. Your son say it's not that old, especially these older guys. All right, multiplied by, let's do it slowly. How many days are in a year? Think about it. 5 points. You're right. 365, but slow down. You got to add something to that. And in this case, it's 8.3 days from what the problem says. So we're going to write 365, right? Plus, how many days they say? It was 8.3 days.
Oh my God, yeah.
Guys. Party hour's not here yet. Come on. So over 1 year, they're like, yes, sir. No. All right, you got to cross something out here. In this case, here's crosses out. Use your cross outs. People have not done that. They lost points. Moving on to our next dimension. Well, let's think about what's next. We got days. Well, how many hours are in a day? That was Nelson, wasn't it? 24, but slow down. Plus what? Let's look at our additions. So the hours is 6.95. The problem tells you to put in it. And that'll be your hour, your days. I messed up. Right? Continuing on. We got, we're in days. We got to get down to hours. 6.95. Look at your problem. 4. It says, let me see the additions part. That's what I'm writing. 6.95 hours, right? So we'll continue on. We got, to get out of days, we look about, days can't stop. So we're in hours. We're going to think about minutes, right? So in 1 hour, you have 60 minutes, but plus something else. 35.6. And this is minutes. This continues on. All right, y'all need to start lining up. A picture will be placed in edsby with the rest of the steps. Line up. Gas in.